In today's tutorial, we will discuss Henderson-Hasselbalch equation or Henderson-Hasselbalch equation. In this tutorial, we will talk about the introduction of the Henderson-Hasselbalch equation. Here, we will tell what is the use of this equation. What is this equation used for? Then we will talk about the equations according to Henderson-Hasselbalch for pH, pOH, pKa, pKb, etc. Okay, we'll find all those equations. We'll tell about equations in short, to the point, about their derivation. So here in third point, we will commence our discussion from this first equation. Then we will move towards the second, third, fourth, fifth, sixth equation. So like this, our discussion will include 8 points. Point number 1, number 2, number 3, number 4, 5, 6, 7, 8 equations. We'll tell you people in short, to the point way, is how these equations are actually derived. So these all will be made simple by means of just this one equation: pH is equal to pKa plus log salt upon acid. Through this equation derivation, I will make you people understand about all these. Then at the end of the lecture, inshallah, you will not feel any sort of confusion. Coming to the point number 1, that is equation use. Now, what is this equation used for? Very simple. For identifying ionic equilibrium, chemical equilibrium, or buffer. We have discussed about ionic and chemical. Now let's come towards the buffer. Now, first of all, what is buffer mean? Simple. Buffer means to resist a change. To resist a change. So here, according to chemistry point of view, biochemistry point of view, and so on and so forth. So according to medical discussions, buffer solution, we discuss about buffer solution. So buffer solutions are actually with us of two types. Number 1, acidic buffer. Number 2, basic buffer. Now, in the beginning, I told you people about the buffer. That buffer is actually meaning to not to change, to resist the change. So we have two solutions: acidic solution, basic solution, acidic buffer and basic buffer solution. So now, what is meant by the term acidic buffer solution? Such kind of acidic buffer solution which will not change its pH if we add any external moiety in certain limits. Suppose we have a solution which is having pH 5. pH 5. So consider it maybe 3 or 4. So remember, very simple, buffer solution regarding acidic buffer solution. So if we have prepared acidic buffer solution which is having pH 3, so now what is the main purpose of this buffer solution, or the main use of this buffer solution? Very simple. If we want a solution not to change its pH, so then we must make that solution in sense of buffer solution. So to make this buffer solution acidic, we must take acid. Along with it, we must take weak salt, weak acid and salt, okay? So, or sort of the same acid and its salt, both should be weak. We'll add them together, so they will give us buffer. And this is depending upon the range, that what sort of range we need, whether it is 3, 4, or 5, whatsoever is the range. Consider what we prepared the entire buffer solution having the pH 3. Now, what is its function? Very simple. If we are adding any external moiety in this particular buffer solution up to certain limit, if we add that external moiety in this buffer solution, which is now acidic buffer solution having pH 3, this pH will remain constant. It will not change. That is the very important and the very cause of preparing what? Acidic buffer solution. The same is the case here for basic buffer solution. If we want to prepare basic buffer solution, first of all, we will take weak base and its salt. We'll mix them together. At the end of the day, we'll get basic buffer solution. Now, this basic buffer solution is such kind of solution which will resist the change in the pH, not pH, pOH. pH is for acidic buffer solution, and pOH, the term, is used for basic buffer solution. So if we are adding now in this buffer solution, we are adding any external moiety in certain limit, in certain concentration. If we are adding this substance into this buffer solution, this basic buffer will not change its pOH. So such kind of solution, if it is not changing its pH or pOH, that solution is actually named as buffer solution. So if that is acidic, then that is named as acidic buffer solution. If that is basic, then that is named as basic buffer solution. Hope it is clear now. Well, here we have certain equations regarding Henderson-Hasselbalch. So we'll start our discussion for the very first point, the very first equation, that is pH is equal to pKa plus log salt upon acid. You must remember this equation for your exams, or sometimes in question paper, this will be written already by your teacher. or sometimes in Viva, this may be asked by your examiner. So it is better to remember this equation. From the single equation, you can remember all these equations. How like you will get to know about this methodology and these all at the end of the lecture. Coming to the point, pH is equal to pKa plus log salt upon acid. Now we'll derive this equation here in very simple terms, in very simple way. So first of all, we are asked in exam, suppose that derive the Henderson-Hasselbalch equation for the pH or for the acid. So remember, this is the equation for the Henderson-Hasselbalch acidic buffer solution. pH is equal to pKa plus log salt upon acid. Now, in order to derive this equation, you must remember the reaction that is supposed to give you the help in deriving this equation. That reaction is very simple. Here we have acid. So this acid is weak acid. It will dissociate into H plus I and A negative. Got? So acid will dissociate into H plus and A negative. This is the equation that you must remember for deriving the acidic buffer solution equation of the Henderson-Hasselbalch. Okay, Henderson-Hasselbalch equation is derived by this reaction, the very first reaction, and this is the equation. You must remember the equation. Okay, if you are going to have an exams tomorrow, for that I recommend you must remember this equation. If you are going for the Viva, you must remember this equation. Anyways, you must remember this equation. Now let's move on to the derivation, how to derive this equation. This is the reaction for the very first step of derivation. Now through this particular reaction, we will derive our equation. How? Like very simple. Now according to the ionic equilibrium or chemical equilibrium derivation, we write here constant named is equilibrium constant. For this we mean that the product is actually divided by the reactant. So here is the product, this is the reactant. The reactant will provide the product. Now take the product and divide it by the reactant, concentration of the reactant. Okay, HA. Now regarding this concentration point of view, sometimes you may write it in some textbooks, this is not mentioned, to write the term concentration around. Anyways, this is the equation, and this is the second step of the equation derivation. Equation reaction number one, step number one, number two, number one, number two. Now let's come towards step number third. Here we got Ka is equal to H plus A negative divided by HA. Okay. Now from this equation, this step, we will look to the equation. This step of the reaction, we will look to the equation. According to equation, we will simplify our next steps. So here in the equation, we are asked about the pH. pH is equal to pKa. So we are going to find pH. Now where is the H here in this step? Here is the H simple alone, individual H. Now we will just keep this H aside and we'll start shifting the A negative HA from this H to the Ka side. Very simple. Just drop the Ka as it is. Ka is here. Now shift whatsoever is in the multiplication form, that will be shifted in the division, and what is in the division, that will be shifted into the multiplication side. In multiplication form. Very simple. Now here this is in the division and this is in the multiplication. So Ka is just now available as like this. We just dropped it down. Now according to A, which is in multiplication, it will come into division. So here we write A negative, and here we have HA, which is in the division. We will just write it here like this, HA in the multiplication. Got? Very simple. Now what remains is just H plus I. Got? H plus is remaining, and we just dropped it down here like this. A negative was in multiplication with the H. We just converted this from this side to this side, and it will shift in the division form. I told you in the beginning, if something is in the division, that will convert into multiplication. If something is in the multiplication sign, in multiplication form, that will be shifted into division form. So here we have A in the multiplication form, so it will come towards the Ka side, other side of the equation, that is Ka side. Now we will write this A in the division form because it was in the multiplication form. Remember, multiplication will be converted into division, and the same is the case here. HA is in division form here at this side of the equation. This is the equal to sign. At this side we have, but at the right side we have, it's mine right. Okay, at the right side we have HA, which is in division form. This will be converted into what? multiplication form, division into multiplication. So division will come here into the multiplication form. Now what we get at the end, this the third step we are done with is having h, that is actually recommended in the beginning. So now what we need is pH. It is just h. So how will we get the pH? Very simple. Before moving towards the pH solution portion, let me tell you people about this particular portion that you might not confused in the fifth step. So here I will add the fourth step. In this, we will just rearrange this particular uh, reaction equation. So now what will you do? This equation, just shift this equation like this. We can say like just rearranging the equation. So first of all, right here h plus equal to, now just take this equation to this side, means we are just rearranging, don't be confused. Okay, here we got a negative, done. So just we rearranged. Now this is h plus with us is equal to ka ha a negative, the same equation just rearranged. In the fifth step, we will just convert this h into pH. How? Very simple. We multiply this entire step with the negative log. Now here comes negative log h plus is equal to negative log Ka, negative log Ha upon A negative. So here we multiplied the entire steps with the negative. Means both the sides of the equations are actually multiplied with the negative log. Now this negative log is actually equal to P. Now wherever you see negative log, put P, just one place where you are not supposed to put P. What is that place? Very simple. Here we have negative log h. This will be converted into pH. Got? Negative log is equal to P and h is just written as it is equal to negative log Ka. Negative log is P, Ka is here with us. Then we have negative log. Now this negative log shall be written as it is. Now coming towards the equation, have we derived yet or not? pH is equal to pKa is equal to pKa plus log. Here we have negative log. Then here we have salt and here we have acid. Here we have got Ha upon A negative. Now what is this? Very simple. In order to solve this step, let me write it here because here it's not visible in the camera. I have just gone through when I was making this lecture in Urdu or Hindi. Well, here is the step. pH is equal to pKa. Now here is positive with us and here we got negative at the end of the equation derivation. Now this negative should be converted into positive log. Remember, whenever you are converting negative log into positive log, whatever is just after it, like here we have Ha upon A negative, this will change their positions. Like they will change their positions. A negative will move upward and Ha will move downward. Means numerator, denominator will change their places. There will be a kind of exchange seen there. So what will happen now? Negative log converted into positive log. A negative will move up and Ha will move down. A negative and Ha. Now we are done with the derivation, but still here we have salt upon acid. Very simple. According to equation derivations, if you remember, when we were writing the ionic balances, chemical balances for the acid-base reactions, we got a statement that A negative is actually the salt the product of the salt. So it was actually placed just like salt in the derivation of the acid-base reactions. So for now, in order to make people understand, in a nutshell, I will say that consider this A negative as salt. So if you want to know more about it, you must go for the common ion effect lectures. Okay, there you will get more about this idea that why A negative is placed as salt. Remember, this Ha is acid. H is the product of the acid and A negative is actually again the same product of this acid dissociation, and this is actually coming with us from the salt side, and we will consider this as salt for now. Okay, so A negative is salt. So now wherever you see A negative in the equation, consider that A negative is salt. So at the end of the equation derivation, here we got A negative. Now what will we do? We will just write it here, rewrite like pKa plus log So told you people right now that consider A negative as salt. So here we got A negative as salt and Ha as acid. So now we can match both the sides, both the equation and derived equation. Here we have pH is equal to pKa is equal to pKa plus log salt upon acid, salt upon acid. It is derived now. Okay. Now the same procedure can be used for POH. So in POH, just you will write BA. So here we have HA, you will write BA, and the rest of the story is just same. And here we have pKa in the third equation, which is actually pKa is equal to pH negative log salt upon acid. Now this equation can come in exams. You will be asked to derive this, and again the story is entire same here. Just at the end you will come here to this side pKa. From this pKa you will derive the entire equation. When you come this place, then just look at the equation that is with you in the beginning, for which is asked for the derivation. pH is equal to pKa plus log salt upon acid. Looking to this equation, pKa can be identified very simply. pKa, write it just here like this. Then just shift the entire side plus log salt upon acid to the pH side. So pH will come here. As if it is moved from this side of the equation to this side, which is in plus form, it will change in minus form. So minus log salt upon acid will come with this. So like this, it will become third equation. Now the fourth equation from the same. If this equation is written in plus form, like pKa pH plus log, the story is the same again. The derivation that's just a moment earlier we just expressed here, like if whenever negative sign is converted into positive sign, what will happen? Whatever is present just after the log term, that will exchange their positions. So here we have pH minus log salt upon acid. So after the log we have salt upon acid. If we are writing the same equation in the positive form, pK is equal to pH plus log acid upon salt. Now acid will move up and salt will move down. This is the way how to rewrite the equation for the pKa in positive form. Then we have pKb, again the same story. pKb is here with us. From the base equation we can derive the pKb. A simple pKb will remain just one side of the equation, and the remaining side will move towards the next side of the equation. So here we get the pKb is equal to POH. It was in plus, so it will move now negative log salt upon base. So as it is moved to the next side, the minus will be converted into plus, plus will be converted into minus, divide will be converted into multiply, multiply will be converted into divide. So these are some rules you must remember, mathematic rules. Okay, so like this, what will happen? pKb is equal to POH negative log salt upon base will be the next equation with us. Now from the same equation we can get the equation in the positive form, like pKb is equal to POH plus log base upon salt. Why? Because we converted negative into positive log. So as we convert negative log into positive log, the base will move up and salt will move down according to rules just I mentioned a moment earlier, here and here. So this is all about the equations and equation derivation of the Henderson-Hasselbalch. For the acid, for the base, the same formula is used. Just write the reaction HB and just go through the same pathway. You will get the equation for the bases. Hope you got. If still you have confusion, drop in the comment box.